Hello. Today we're going to talk about the nearest neighbor interpolation. Nearest neighbor interpolation is just a simple way to estimate values when we don't have an exact data point, and we have to estimate the value of a point based on where the sites are in the Voronoi diagram. So basically what we do is we use the sites, and if the sites has measurements or if the site has takes on a certain value, then any point that is in that region where the site is going to also take on that value. The only time when that is not true is whenever you have a point that is halfway or equal distance from two sites, meaning that the point lies on a bisector or it lies in the intersection of more than one bisector. And then when that happens, you have to take the average of the points that they're halfway in between. So let's look at an example here. So this example says David measured the temperature in his city at three locations X, Y, and Z, which are marked on the map. The results are shown below. So site X has a temperature of 91 degrees Fahrenheit, site Y has a temperature of 87 degrees, and site Z has a temperature of 94 degrees. So it says use the nearest interpolation to estimate the temperature at 0, 3. That's the first point. So if I go to my graph and I plot 0, 3, I am here. And you can see that that point lies in cell X because that is the site that's closest to it. So that means that this point will take on the value of 91 degrees Fahrenheit, just like site X. All right. The next one that we need to estimate the value of is the point 1, -7. So if we go to 1, -7, as you can see here, this point lies on the bisector, the perpendicular bisector that goes in between Z and Y. So I have to take the average of those two because this orange point, 1, -7, is literally halfway between Z and Y. So they are the same, that point is the same distance from Y as it is from V. So I have to find the average. So in order to find the average, all we have to do is add Z and Y together. So that's 87 plus 94. And you want to divide that by 2, and you get 90.5 degrees Fahrenheit. All right. The last point that we have here is 2, -5. So if I graph 2, -5, that point lies here and it is in the cell where Y is. So it's going to take on that same value. So Y has a temperature of 87 degrees Fahrenheit, which that point will take on as well. Okay. All right. So let's talk about the largest empty circle problem. So the largest empty circle problem is basically about finding the biggest possible circle that is going to fit inside of a Voronoi diagram or an area or region without having any of the sites inside of it. So basically, think of it like having a toxic waste dump or a toxic landfill that you are trying to put in the middle of some cities, but you don't want any of the cities to be affected um by the landfill. So those cities need to be outside of the radius of that landfill so that no chemicals or anything will not pollute the air. So what you have to do is that you will realize with a Voronoi diagram that the center of your circle has to occur at a vertice that is in your Voronoi diagram. So basically, what you have to do is you have to compare your vertices to a point that is equidistant. Okay. So a point, so you have a wherever your bisector is, wherever your vertex is, you want to look at those vertices and compare them to one point. Okay. So to figure out which vertex is going to cause the greater distance between that point, because that is where you want the center of the largest empty circle or your toxic waste dump to be. You want it to be as far away as possible. So what we do is if we look at example 1, We have a Voronoi diagram for the sites A, B, C, and D. We want to find the largest empty circle for these sites. So if we look here, we see that we have two vertices. I have a vertex here. I'm going to call this vertex 1, which is located at -3, -2. And then I have another vertex here, which I'm going to call vertex 2. And this vertex is located at 0, -1. All right. This is at 0, -1. And then we have to figure out a point that is going to be equidistant from both of these. So one thing that we should notice, okay, one thing that we should notice is that these two vertices lie on this bisector that I'm highlighting here. And that bisector that I highlighted is the perpendicular bisector between A and C. So vertex 1 and vertex 2 are both the same distance to point A as both of them are to point C. So I can choose either point A or point C to compare the distance of these vertices to. So I am going to use point A, and point A is located at -1, 2. All right, so what I need to do is I need to find the distance between each vertice and the point here. Okay, so if I do that, I will end up having to apply the distance formula. And we should remember that the distance formula between 2 points is going to be x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, so that is the distance formula. So we're going to apply it. Remember, it does not matter which point is the x1, y1 or the x2, y2, as long as you keep things consistent. That is the most important part. So what we're going to do here is we're going to look at vertex 1 and point A. So the distance between vertex 1 and point A, I'm going to make my vertex 1 the x1, y1, and point A is going to be the x2, y2. So if I were to solve this, I would have -3 subtract -1 squared plus -2 subtract, and it should be -3 subtract, correct, subtract -1, and then -2 subtract 2. Okay. Remember, make sure you're going in the same order. All right. So be careful. So if I were to simplify this, I would have -3 minus -1 squared plus -2 minus 2 squared, and that will give me the square root of 20. And we know that the square root of 20 is approximately 4.47 units. So now I want to do the same thing, except I'm going to test vertex 2 to point A. So I know that my distance here is going to be equal to 0 subtract -1 squared plus -1 subtract 2 squared. All right, so we know that 0 minus -1 is a +1. So that's 1 squared plus -3 squared. So that's the square root of 10. And the square root of 10 is approximately 3.16. So as you can see here, vertex 1 is going to have the greater distance from point A. So that means that that's where my center needs to be. So the center of this circle needs to be located at -3, -2, and the radius of this circle is going to be equal to the square root of 20, because that's going to create the largest distance between the center and site A. All right, so that's how that circle needs to be drawn. A circle with a center of -3, -2, and a radius of square root of 20 end up making that the largest empty circle. So let's look at example number 2. Example number 2 says find the center and radius of the largest empty circle for these set of sites. So as we can see here, we have 4 sites and we have 2 vertices. We have one vertex here. I'm going to call it vertex 1, which is located at -2, -1. And then we have another vertex here, which is located at -1, +1. So that's vertex 2. All right. So what we're going to do here is we have to understand that on this bisector, vertex 1 and vertex 2 lie on this perpendicular bisector here. And this perpendicular bisector is going to separate E and G. All right. So we have to compare these 2 points to either point E or point G. All right. So I'm going to use it to compare to point G, and point G is located at -4, 0. All right. So we have to find the distance between vertex 1 and point G. So in order to find that distance, we are going to take the square root of -2 minus -4 squared plus -1 minus 0 squared. All right. So we know that -2 minus -4 squared plus -1 minus 0 squared is 5. So this is going to be the square root of 5. And the square root of 5 is approximately 2.24 in 3 sig figs. Now we want to compare it against vertex 2. So vertex 2 and G, the distance will be -1 minus -4 squared plus +1 minus 0 squared. All right. And remember, you got to make sure you, if you need to, label your points x1, y1, and x2, y2 if you need to, so you don't get them mixed up. So we have -1 minus -4 squared plus 1 minus 0 squared. We get the square root of 10, which we already know from the previous problem is 3.16. So as you can see here, vertex 2 is going to create the greater distance. So the largest empty circle needs to be written at the center, -1, +1, and it needs to have a radius of the square root of 10. All right. And then that will be what our answer is. Okay, so we know we need to have a center at -1, +1, and a radius of 10, right? And sometimes you can visually tell, but you still have to do the math to find the radius. Okay. So you may be able to visually look and tell what the center should be, but you have to do the math and find the distance to find the radius. You cannot skip that step. Right. If you have any questions, please reach out to your teacher and have a great day.